In this video, I will discuss a little bit some basic properties of electric forces. Let's say that we have a charge Q1 right here and a charge Q2 right here. We know that the electric force from charge 1 on charge 2 is given by this expression, the constant 1 over 4 pi epsilon naught Q1 times Q2 divided by the magnitude of the r vector from 1 to 2, and that is squared, times r hat. Now, this quantity is essentially the distance between the two charges, the distance between charge 1 and charge Q2. Now, in this case, let's say that I have a charge Q1 that is equal to E, where E is 1.6 times 10 to minus 19 coulombs. And let's say that Q2 is also equal to E, the same quantity. Since these two charges are both positive, there is a repulsive force that points away from charge Q1. This is the electric force from charge Q1 on charge Q2. Now, what I want to show you is what happens when you change charge Q1. So let's say that I have again charge Q2 as before, and now instead of having the charge Q1, now I have a charge Q3 that is equal to 2 times E. Now I have 2 times the charge that I had in the previous case. Looking at this expression over here, we see that the electric force depends linearly on the charges Q1 and Q2. This means that if you double the charge Q1, as we did right here, now we have a charge of 2E, the electric force from Q3 on Q2 will be 2 times as large as we had before. So, for example, in this case, we will have this electric force from charge Q3 on charge Q2. Now, this would also be true if instead of making charge Q1 double, if I had made the charge Q2 2 times E. If you make both charges Q1 and Q2 2E and 2E, then the force would become 4 times as large because you would have a factor of 2 here and a factor of 2 here. Now, this assumed that we kept the distance between the two charges the same. I did not change the distance as I went from this pair of charges to this pair of charges. Now, if I affect the distance, if I increase, for example, the distance between the two charges, this will affect the electric force. So, for example, let's say that I have charge Q1 as I had before, and now I bring charge Q2 at 2 times the distance that I had before. So I am right here, and this is charge Q2, the same as before. Now this distance is 2 times the distance that I had here. Because the distance in the denominator is squared, doubling the distance over here will make the electric force become 1/4 as large as before. And this is because the factor of 2 is also squared in the denominator. So the electric force now from Q1 on Q2 will only be 1/4 of the electric force that we had before. So now this is the electric force from charge Q1 to charge Q2. So it is important when you work with electric forces to keep in mind that the electric force depends linearly on the charges, but it depends on the square of the distance.